Here's some written solutions to this question, paper 2 question from 2016. We already found the height when it was fired. T was equal to 0 there. So T equals 0, evaluate the function. And then that was 12. So H of 0 is 12. Okay, and then find the height, 15 seconds. So you got to plug in T is equal to 15 to the function up here. So again, you're going to get negative 0.2 times 15 squared, square 15 first. So again, that's 225, a fifth of 225, negative a fifth is negative 45, I think. And then this is 16 times 15, 240, plus 12, 252 minus 45. H of 15 is 207 meters. Okay. And then find the value of K. We could do that using the quadratic formula. Not very easily. And then we can find the derivative function using the power rule. And then we can show on F, figure out the heights. Again, we could go back and use the quadratic formula if we want to do it written. And then the total length of time the flare can be seen. Yeah. All right, so some of the formulae I'm going to use. You can see the formula here. The formula for the equation of the axis of symmetry. This is where the vertex is, the x location. So again, I can use that to find the height, the maximum height of the flare. And then down here is the power rule. You take the n down front, multiply it times a, then times x, and then you have to take away 1 from the exponent, 1 from n. All right, so moving along, you want to find t equals the value for when the equation is equal to 0. So this is question C. Zero is equal to negative 0.2 t squared. Again, on my calculator, I called it x. Plus 16t plus 12. Ooh, this is not going to be fun. So A is equal to negative 0.2. B is equal to 16. That's a t plus 12. And then C is equal to 12. X, or t in this case, is going to be negative b plus or minus b squared, square root of b squared minus 4ac, the discriminant over 2a. So t is equal to negative 16 plus or minus the square root of negative 16 squared. You have to put that in brackets. It's going to always, b squared is always positive. And then minus 4a is negative 0.2, and then c is 12. Okay, that's the discriminant, and then 2 times negative 0.2. And I'm going to need a calculator to do all that. But again, I'm going to get a negative solution and a positive solution. And if I do this correctly in my calculator, I'm going to... That is equal to 80.7 seconds for when it gets back down into the sea. H is equal to 0. All right, so the function, we're going to take the derivative. H of t, same function. negative 0.2 t squared plus 16t plus 12. Okay, so you're going to use the power rule to find the derivatives. The power here is 2. The coefficient is negative 0.2. So the first term is 2 times negative 0.2 times t to the 2 minus 1 power. Second term, there's a 1 up here, invisible. 1 comes down front, times 16 t to the 1 minus 1. No t here, so that means that it's like multiplying times 1, t to the 0 comes down front. 0 times 12 is 0, t to the 0, it doesn't matter, anything times 0 is 0. Anyway, the derivative of a constant is 0, so that's going to go away. Bye-bye. H prime of t, try and make it more of a prime. Negative 0.2 t to the 2 minus 1 plus 1 times 16 t to the 1 minus 1. So again, h prime of t, 2 times negative 0.2, negative 0.4, t to the 2 minus 1 is just t to the first. Again, this is 1 over here. That's 1, okay. And again, the derivative of 12 was 0. Plus 16. There's the derivative. All right, so I said that I could use calculus to find the maximum height. Well, it's a parabola. And the maximum height is basically when the gradient of the function is 0. So again, the tangent line, this means h prime is equal to 0. The gradient of the tangent line is 0 at a maximum. We get this in chapter 21. So I could solve the time. What time is it at the maximum? I could solve this equation. So I want to solve the gradient equation for it equal to 0. Okay? So again, I'm just going to do 0 is equal to negative 0.4 t plus 16. Negative 16 is equal to negative 0.4 t, and then I just do t is equal to negative 16 divided by negative 0.4, and I get 40, as I'm supposed to. So I could have solved that problem using calculus.